Now that we're familiar with some of the parent functions in their home spot, what we're going to do is shift them around. So the first thing we're going to look at is horizontal and vertical translations. So shifting them left and right and up and down. So in general, y equals f at x plus c. So this would represent your parent function here. And then we would add on some number for c. If c is greater than 0, the graph is going to be translated c units up. And if c is less than 0, the graph of f at x is going to be translated c units down. Now for the horizontal translations, in general, we have this expression here. So y equals f times, or f at x minus d. If h is greater than 0, the graph of f at x is going to be translated h units to the right. If h is less than 0, the graph of f at x is going to be translated h units to the left. So let's take a look at, and let's change this to d because d is what we use here. And let's take a look at some examples here to see how that works. Okay. So what we're going to do is sketch the function and state the domain and the range. So here I've got y equals x squared minus 1. So my parent function is a parabola. And I know that my parabola has a shape, in general, something like this. This is my y equals x squared. I see that minus 1 at the end, and I know that this is a vertical shift down by 1. So I'm going to draw my new one in red. So I'm going to take my vertex, I'm going to shift it down 1. I'm going to take my 0.11, shift it down 1, and I'm going to take the one on the opposite side, and then I'm going to connect my points to draw a sketch of my parabola. So y equals x squared minus 1. So now I'm going to state my domain and range for the new red parabola. My domain is still the same. I've got all possible x values. My range is a little bit different because now I've shifted my vertex down. So my new range is going to be all the way from minus 1 inclusive all the way to positive infinity. Let's look at another example. So here I've got y equals x minus 5. Now what this really means is that this is my shift. So because I've got minus 5, that means that my d value is actually greater than 0, which means that I've got to shift to the right. One of the ways that you can remember it is that the horizontal translation, the shift is always the opposite of the sign that is in the function. So if you have a negative sign, that means we're shifting to the right, even though the actual value for the translation coefficient, if you will, is positive. So what we are going to have here is we can see that our parent function, is going to be the square root function. And I know that that looks kind of like this. So I've got 1, and then I'll draw 1, 2, 3, 4, one more point. And then I know that it sort of goes up like this, like a sideways parabola. So now I'm going to shift that horizontally 5 spots to the right. So 1, 2, 3, 4, 5. I'm going to take my next point. I'm also going to shift it 5 to the right. And then my last point here, I'm also going to shift 5 to the right. 1, 2, 3, 4, 5. And now I can do the same thing, make the same general shape for the function that I've been asked to graph. Now I'm going to state my domain and range. So my domain has changed because I've shifted my starting point for the square root function. So now I start at positive 5 and go all the way to infinity. And my range is still the same, all the way from 0 to positive infinity. Let's do another example. So here we're given our translation information in a little bit different scenario. So we've got our parent function here. This is our parent. And then here we have our translation described in function notation. So there are two things that are happening here. The first one is going to be a horizontal shift left 1. The second thing that's happening is a vertical shift up 3. So we've got two things that are happening here. Now I know my parent function has a point at 1, 1 and negative 1, negative 1. And I know that it goes sort of down like this and up like this. This is my parent function. And I also know that I've got asymptotes on my axes. So I'm just going to sketch those in there so we can see what we're moving. So we've got y equals 0 and x equals 0. Now what it says is a horizontal shift left and a vertical shift up 3. So let's do the asymptotes first. I'll do them in green. So what that means is that my horizontal asymptote, okay, which is here, y equals 0, that is going to go up 3 spots. So 1, 2, 3. And then I've got a new location for my asymptote. And I've now got y equals 3. And my horizontal shift means that my horizontal asymptote is just going to go left by 1. And I've got my new equation for my asymptote. So now the next thing that I need to do is to sketch my new function. So that means that I need to shift my points as well. So my first point, this 1, 1 point here, I'm going to shift it left 1 and up 3. And then I'm going to draw the general shape of that graph down to the horizontal asymptote, up to the vertical. Then I'm going to do the same thing with my other point, left 1, up 3. And then I'm going to draw my general sketch here. And then I can label my red function that I've drawn, which is my translated version of the parent function, the reciprocal. The last thing that I need to do is state my domain and range. So this is the tricky one. I'm going to go all the way from minus infinity to minus 1 horizontally. And then I go from minus 1 to positive infinity. And then my range is going to go all the way from minus infinity up to my horizontal asymptote. And then continue on from my horizontal asymptote all the way up to positive infinity. You should also be able to transform a piecewise graph. And so for the function shown here, doesn't really have a parent graph like we did in the previous example. But what we want to do is describe how this graph here can be obtained from f at x. So we've got two things that are happening here. Two numbers. So I would shift right 4, and then I would shift down 2. And then what we're asked to do is to graph this here. So here I'm going to identify my transformations first. So I would shift right 2, and then I would shift up 3. When you have a piecewise function, that is as simple as moving all of the corner points and then connecting them. So I'm going to go shift right and shift up. Same thing over here, shift right, shift up, and I'm going to use my ruler to connect those two. And then I'm going to repeat down here. So shift right 2, 1, 2, 3. And then shift right 2, oops, this point here, right 2, up 3, connecting my points as I go. And then my last one, I'm going to shift right 2, 1, 2, 3, probably right about here. And then I'm going to connect those 2 dots. And this gives me my graph for 2 with a shift right 2 and then a shift up 3. The last thing that we're going to do is state the domain and range for the following without graphing. So you should be comfortable doing this without graphing. It will save you some time in making predictions later on. So for my line, y equals 3x plus 2, doesn't matter the equation of the line, my domain and my range are always the same, all possible real values. For b, now I've got a parabola, and I know that my vertex is at 3, 5, and my parabola is opening up. So my domain for a parabola is always all real numbers, minus infinity to positive infinity. But my range is just going to start at the y-coordinate of the vertex. And then continue on to positive infinity, because in this case, our parabola opens up. Next is our square root function. Here we've got a horizontal shift, right 2. That means that our starting point is no longer 0, 0. Our starting point is going to be 2, 0. So that means that our domain now starts at 2, continues on to infinity. The range remains the same, starting from 0 and going all the way up to positive infinity. Next one is the square root function again, but it's a little bit more complicated. I've got 2 shifts to note here. I've got a horizontal shift left 4, and I've got a vertical shift down 2. So that's going to change two things about this graph. So the first one that's going to be affected is my horizontal shift. So now my graph is going to start at -4 and go all the way to positive infinity. My range now, instead of starting at 0, 0, is going to go down by 2. And so I'm going to start at -2 and work my way up to 0. E, I've got a parabola again, but this time it's in standard form. So I want to complete the square to put it into vertex form. So first, factor out the negative. Second, add and subtract. Bring that out at the same time to make the perfect square that you can factor. And then I've got x minus 3 squared plus 14. Once I factor that perfect square trinomial, that tells me that my vertex is 3, 14, and my parabola opens up, opens down because of this negative here. So my domain is still going to be all real numbers. That hasn't changed, but the location of my vertex does affect the range. So my range is going to go from minus infinity, so my lower number, all the way up to 14. So starting at my most negative number and going to my least negative number, we write it this way because my parabola is opening down. The last one here is the absolute value function. So here we've got a horizontal shift left 2, which means that my domain is going to remain the same. And my range is affected here, just the same as the regular function. There's really no difference made by shifting the absolute value function horizontally. So you should be able to shift any of the parent functions left and right and up and down. You should be able to state the domain and range, and you should be able to understand the horizontal and vertical translations as it applies to function notation as an example 2.